Have you ever looked at a massive cruise ship or a sprawling chemical plant or a skyscraper just touching the clouds and thought, how? How in the world do people organize something so impossibly complex? Okay, let's get into it because the answer is this really fascinating mix of big picture strategy and almost microscopic detail. Just think about that for a second. We're talking about projects that can take years to finish, involving thousands of people, all this specialized machinery, and just countless moving parts. Building a single ship, it's like orchestrating a small city. So really, how do you even start to map out a project where just one delayed bolt could throw the entire thing into chaos? That's the big question we're going to tackle here. So the whole framework for handling these enormous tasks actually has a name. It's called project production. And it's a completely different way of thinking about manufacturing than, say, how we make cars or smartphones on a typical assembly line. Right, so here's the key idea. These are one-of-a-kind things. Every project kicks off with a unique order from a customer. And from there, it's this long journey from design and getting materials, all the way through construction, assembly, and finally installation. We are absolutely not talking about mass production here. This is all about masterclass, completely custom engineering. And this just shows you the incredible scale we're dealing with. You've got everything from the tanker ships that move pretty much all of global commerce, to the power plants that light up our cities, to those iconic bridges and stadiums that really define a skyline. Heck, even super specialized, custom-built machines for a factory floor. Yep, that falls under this umbrella too. Each and every one is a massive, individual undertaking. Look, if building these things were easy, we'd see them everywhere. But it is incredibly hard. Why? Because any team that tries to schedule a mega project immediately slams into four huge confronting walls that stand right in the way of a smooth plan. And getting even one of these wrong, well, that can lead to those crippling delays and the insane budget overruns that these kinds of projects are so famous for. So let's break them down one by one. So, first up, you hit the wall of complex dependencies. Just picture this enormous web of tasks. You can't put in the wiring until the walls are framed up. You can't frame the walls until the foundation is poured. Okay, now, multiply that by 10,000. Every single task is linked. A big part of managing this is something called the critical path method, which is basically mapping out the longest possible chain of these dependent tasks. That tells you the absolute minimum time the project will take. It's a huge, huge challenge. Next, you slam into the wall of resource conflicts. So you only have so many expert welders, you've got a limited number of giant cranes, and you've only got so much physical space to actually do the work. What happens when multiple teams need the same crane on the same day? The challenge is to allocate all these finite resources perfectly so you don't get bottlenecks, competition, or worse, super expensive equipment just sitting around doing nothing. Then there's the wall of uncertainty. Because no plan, no matter how perfect, is safe from the real world, right? A week of horrible weather can stop all your outdoor work cold. A key supplier might miss a delivery. The client might suddenly ask for a last-minute design change. And any one of these unpredictable things can send a shockwave through the entire schedule, meaning the whole plan has to be adjusted, like right now. And finally, you have the wall of information gaps. These projects involve tons of different departments and outside partner companies. So how do you make sure that everybody, from the engineers in the office to the foreman on the ground, is working from the same up-to-the-minute playbook? If you don't have that single source of truth, work can just grind to a halt, simply because one team had no idea that another team had finished its part. So how do you break through these four walls? Well, this is where it gets really clever. You can't just use one tool. The secret to stopping those infamous delays and budget blowouts is actually using two totally different types of planning systems together. One gives you that 30,000-foot view, and the other tells you exactly what's happening on the ground right now. This slide really breaks it down perfectly. So over on the left, you've got the project management system. You can think of this as the master architect. It's looking at the entire project over months, even years. It's asking the big questions like, what are the major phases, and when do they absolutely need to be done? But then on the right, you've got the production scheduler. This is your on-site foreman. This tool is worried about the minute-by-minute plan. It's asking which specific machine is going to cut this specific steel beam at 2:05 p.m. on Tuesday, and crucially, is that machine even available? See the difference? And here's the thing, you can't just choose one. The real magic, the real power, happens when you combine them. Getting these two totally different views of the world to talk to each other seamlessly, that is where you find true efficiency and control in project production. I just love this quote because it sums up the whole philosophy so well. You use that project management system to build the skeleton, the high-level structure, the major milestones, the overall timeline. But to put the muscle and the tissue on that skeleton, all the actual detailed manufacturing work, that's where you need the incredible precision of a production scheduler. So let's walk through how this all comes together. First, you create the skeleton. You define the main phases. Easy enough. Second, you flesh out all the details. You use the scheduler to create these hyper-detailed, minute-by-minute plans for every single component. And then, and this is the most critical step, you link and synchronize them. What you get is a living plan. And this plan directly attacks those four walls. A delay on a single machine on the factory floor automatically updates the big picture timeline. This lets managers see the impact instantly, and that's how you stop a small problem from cascading into a costly disaster. It's by mastering this combination, this blend of big picture oversight and ground-level detail, that we're able to build these modern wonders. It's a system that allows for both grand vision and flawless execution. Which, really just leaves one question. With tools and methods this powerful, what incredible thing is humanity going to decide to build next?